Here we have the box of electrical bits. That's an Arduino with stepper motor hats. That's the relay that drives the Z motor. That appears to be mains cable, which is it's been tied up with a piece of wire with DuPont connectors on each end, which makes it look like something other than what it actually is. More DuPont connectors. These, I believe, are the extension wires for the motors. And according to the instructions, that's the first job. So, just checking to make sure I haven't got those guide rods in another form, unlikely since I've clearly got two that are the wrong size. So, what we have here is a soldering iron job. This little bundle, which if I'm not careful is going to finish up in knots. One, two, three. That's interesting. We have DuPont connectors on this end, and on that end, but according to the video I'm supposed to cut these to connect to the motor. I think I better revisit that because I don't like the idea of cutting those unnecessarily. Colours: blue, red, green and black. Blue, red, green and black. Those certainly appear to be correct. How long do we want these? Surely we don't need them as long as that. Mind you, it does depend, I suppose, on where we put the driver. I'm going to sheath these. In the instruction video, these are shown being soldered and taped together with electrician's tape, which is a pretty disgusting way of doing it. I'm almost tempted to put sockets on there, but I don't think so. What I'll do is I'll cut these, I'll cut them fairly long, solder them and then sleeve them with expanding rubber sleeves, and then encase the whole thing in spiral wrap, which should do a nice neat job. Well, I'm not going to make you sit through me soldering a load of wires together, so I'm going to terminate the video there and we'll come back when I've finished that. Okay, we're back. We've had a lot of soldering to do. Very fiddly job. If you're the sort of person who can't work with small objects and finds fiddly detail too much to bear, you might want to get somebody else to do this for you. Basically, you extend the stepper motor, well, each of the three stepper motors with a plug on the end. There we are, X, Y and Z completed. Now the next step, according to the video, is to wire in this little relay board, and it's fairly straightforward, except for the fact that the colours on these cables don't correspond to what the video actually talks about. This actually is the signal. It's fairly straightforward. This is the signal cable. In my case it's an orange cable. I get the feeling it could be any colour, you never know. But it's a single DuPont connector on one end. The other end had a DuPont connector on it, but I've cut it off and tinned it because it's going to go into this relay connector. And one of the relay connectors, the one that's furthest away from the relay itself, has 3 connections. What have I done with my decent screwdriver? Never mind, this one will do. 3 connections, DC positive, DC negative, and the actual control line itself, which is labelled in. Now that really is a disgusting screwdriver, I can't use that. Bear with me. What have I done? What have I done with my screwdriver? Okay, let's go for that. Use one of my jeweler's screwdrivers. So this one is the in pin. So I'm going to put the single wire in that. And then we've got DC positive and negative. I'm going to go with convention. Black is going to be negative for me. And I'll have brown as positive in there. That's easy enough. If we take the power connection, positive and negative DC, there are 2 places on the control board where we can plug it in. One is just by the USB socket labelled 5 volts ground, and the other one's on the other side on this little set of isolated pins over here, this set of pins, and again labelled 5 volts and ground. I'm going to plug it into the one that I can see most obviously. 5 volts and ground there. And the actual control is spin enable, and on this board spin enable is just there. So can we see that? Will the camera focus on it at that distance? Now then, the remaining circuitry consists basically of this length of wire, which came as one piece. I've cut about a foot off one end of it, and the other length I've cut in half. I've tinned all the ends, and on one of the longer pieces I've actually opened it up in the middle, broken the red wire, and tinned the 2 ends, because that's where the relay connection is going to go. So I'll plug that in there now, and it goes into the common, obviously. and the normally open connection. A little bit too much solder on that end. There. Now, the tricky bit is remembering what I'm supposed to do next. In the bag with the motor, there are some spade terminals. Bit of a strange place to put them, but there you go. And another Allen key. One, and its cover. Cover. Proper collection of little bits in there. I don't want to lose any of those. Seal that up. Right, excuse me a moment. Okay, I think I remember. This piece, the short piece, this is the power input to the control board. Okay, well that wants to go into this terminal block here. Positive and negative, you can't really get these things wrong. Positive, negative. Those are perhaps a little long. I could do perhaps with shortening them. This, by the way, is a piggybacked Arduino. It's a Uno. And the supply comes down. Now you've got 3 of these plugs and a socket. Obviously one of the sockets goes with the plug and the other plug, what am I talking about? The socket goes with one of the plugs. The plug, you have to connect positive, negative. Again, it's actually marked on the body. Positive is there. Negative there. And this one, this is the control for the main motor, as I mentioned before. That's connected by spade terminals and this plug and socket just as an extension, with the remaining the remaining plug going at the other end as a power input. So that's basically the wiring scheme. So we wire it up. I do have some better spade terminals than these, but I think I'll live with these. They're not the nicest I've ever come across. Slide the boot over it. And we want socket this side, plug this side around. I keep saying plug when I mean socket, socket when I mean plug. Positive. And negative. Positive. Negative. Let's actually connect up the motor just for laughs. Oh, important to get the polarity right. It is a DC motor. Positive, negative. A big lump of fluff courtesy of China. Yuck, what is that in there? Looks like half of somebody's pullover got inside the machine while it was being assembled. There's a great lump of felt stuck in there. Well, it doesn't seem to have gone too far into the motor. We'll live with that. One last connection. Trim that. And there we have it. From here it's just a matter of plugging in the 3 XYZ motors. It isn't too clear which way around these go. This is the X. I suppose the direction probably is decided by which way around you plug these in. there's no polarity indicated. I'll check that because I can pull up the specs on this particular CNC shield. It's a fairly common type that I've seen around before, so I'm pretty sure there won't be any problems there. And there we have it. One completed control system. We have two input connectors, presumably for the two power supplies. This one is a 12-volt supply, and this motor, it doesn't actually say anything on it, well, not in any recognisable symbol. I'm tempted to do my impersonation of Harry Seacombe there, but I don't think I will. And oh, we've looked at that one. That's the 12 volt one, which I think is very probably for this. So that will plug in to this. And this meteor looking thing, I would expect, is for the stepper motors. 24 volts at 6 amps, that's quite a big chunk of meat. That plugs in there. Now, in case you're wondering, the Arduino doesn't need any power because it gets its power down the USB line from the computer itself. So that's the completed setup.